Alright, so let's review the three forms of quadratics. So whenever you're working with a problem that deals with quadratics, you have to think about the information that's given to you and which form you should use. Okay? So a quadratic can be written three different ways. It can be written in standard form, vertex form, or x-intercept form. Okay? So in standard form, right, so here's an example of a quadratic in standard form. If I wanted to, I can rewrite this quadratic, right, in vertex form. In vertex form, it would be written like this. And in x-intercept form, it would be written like this. Okay? So this is actually the same quadratic written all three different ways, right? So that you guys understand that a quadratic can be written, right, three different ways. Okay? So whenever you're working with quadratics, you have to think of the information that's given to you and which form you should use. Okay, so let's take a look at some examples. All right, so let's take a look at this example here. So looking at this problem, all right, so the first thing you should recognize is, okay, they're giving me this problem in standard form, okay? And then we need to find these things here. Now, A says find the equation for the axis of symmetry, right? So the first thing you need to remember is the axis of symmetry, all right? This right here is equal to, all right, so this is equal to the x value of the vertex. Okay? Now, in standard form, right, when the quadratic is in standard form, remember to find the x value of the vertex, right, it's negative b divided by 2a. So for part A here, if I need to find the equation for the axis of symmetry, right, basically I'm trying to find the x value of the vertex. So we have negative b, which is negative 2, divided by 2 times a, which is negative 1. So we end up with positive 2 divided by negative 2. We get negative 1. So the equation for the axis of symmetry is x equals negative 1. Okay? So the important thing to remember, the axis of symmetry is equal to the x value of the vertex. Okay? The axis of symmetry and the x value of the vertex are the same. Okay, and when the quadratic is in standard form, to find the x value of the vertex, right, we calculate negative b divided by 2a. Okay, let's take a look at part B. So part B says find the x-intercepts. Remember, to find the x-intercepts, all right, we make y equal to 0. So when you make y equal to 0 here, you get 0 is equal to negative x squared minus 2x plus 8. So what I'm gonna do is, well, I want the x squared to be positive, so I'm gonna factor out a negative 1, right? So I take out a negative 1, I get x squared plus 2x, and then minus 8. Now if I divide both sides by negative 1, it's still 0 on the left side, so this will still be 0. The negative 1 will be gone, right? And then I'm gonna factor this. This would be x plus 4, x minus 2. So what are the values that will make this 0? Well, x is negative 4, x is equal to positive 2. So my x-intercepts, right, are negative 4 comma 0, and also 2 comma 0. So these are my x-intercepts. Okay, so that's part B. Let's take a look at part C now. Part C, let me get some space here. So part C says find the y-intercept. All right, find the y-intercept. So the y-intercept, right, we make x equal to 0. So if I plug in 0 here for x, it seems real obvious. Y is going to equal negative 0 squared plus, minus 2 times 0 plus 8. So that's going to leave you with just 8. So the y-intercept is 0 comma 8, right? And then part D, it says find the vertex, okay? Now remember earlier, the x value of our vertex, we calculated this already, right? This was negative 1. So now we just need to find the y value of the vertex. Remember, to find the y value of the vertex, you just take the x value of the vertex, you plug it into the problem. So to find the y value of the vertex, right, we have negative, parentheses, negative 1 squared minus 2 times negative 1 plus 8. Then we just work this out. So it looks like this is going to leave me with a -1 plus 2 plus 8. So we're going to end up with, that's going to leave me 9, right? So the coordinates of the vertex, right, is -1, 9. Okay? Let's take a look at this next example here. So this time we're given a graph, right? So we're given a graph here. And we need to find the function in the form f of x is equal to a parentheses x minus p times x minus q. So they want us to write this graph in x-intercept form, okay? So the first thing you need to recognize is, okay, they want the answer in x-intercept form right here, right? So they want this in x-intercept form. So if they want it in x-intercept form, I want to see if I know the x-intercepts. So looking at the graph here, I can tell that the x-intercepts, which are right here and here, so the x-intercept is 3 and the other one is -1. Okay, so basically remember these are your p and your q values. Now, so when you plug it into this form, right, when you plug it into x-intercept form, so we don't know the a right now. Now remember when you plug it into these parentheses, all right, it's x minus, all right, -1. So you notice this minus was already here, right? So it's x minus and then whatever p is -1, times x minus whatever q is 3. So we know a negative becomes positive, okay? So now we need to find out what the a value is. To find the a value, we just take any point that's on the parabola and plug in the x and the y. For example, I can use this point right here, right? Because the coordinates here is 0, 9. This could be my x and my y. I can plug it into the problem and solve for a, right? Or you could use a different point. It doesn't matter. You could use any point that's on the parabola. You could even use the vertex. The vertex is at 1, 12. You could use this point, all right? You could use this x or this y as well. So you can use any point as long as it's on the parabola to solve for the a, right? So I'll just use the 0 and the 9. So remember this f of x, you could think of this as y, right? So we have 9 is equal to a times 0 plus 1 times 0 minus 3. So if we work this out, this is -3a is equal to 9 divided by -3. So we get -3 is equal to a, right? So if we write this equation now, it's going to be f of x is equal to -3 parentheses x plus 1 times x minus 3, right? So this would be our answer for part A. Now part B, they're asking us, okay, so what's A, P, and Q, right? So we've done all the work already, we just need to state it. So first of all, we know A, we calculated that, that's obvious, that's a -3. Our P value, remember over here, and our Q value, so P was -1, Q, all right, is +3, okay? All right, so let's take a look at this example here. Find the equation for the axis of symmetry, okay? So first of all, you need to recognize that, okay, this time I'm working with the quadratic in x-intercept form, right? So find the equation of the axis of symmetry. Now remember the axis of symmetry, we talked about this earlier. The axis of symmetry, right, is equal to this x value of the vertex, right? So if I can find the x value of the vertex, I've also found the axis of symmetry, okay? So for part A here, so we need to think, if this is in x-intercept form, right? So remember my p value and my q value, right? So remember this will give you your p and your q values, but you have to take the opposite sign. So you have to think of this as p is -1, right? And q is +9, all right? Q is equal to +9. Now remember, these are your x-intercepts. That's why it's called x-intercept form. So if these are your x-intercepts, let's kind of make a little sketch. So that means that the parabola is going to cross through -1 and +9, right? So remember, the vertex is going to be in the middle. So if it's going to be in the middle, so let's think. How far apart are we from -1 to +9? From -1 to +9, we're 10 spaces apart. So we're 10 spaces apart. So that means the middle, right, is going to be 5 spaces. So from -1, you can move to the right 5 spaces. So where would that be? From -1, if we move to the right 5 spaces, we're going to be at +4, right? So we know the vertex is going to go through +4 on the x-axis, right? So our vertex, we know the x value is going to be 4, right? Now the x value of the vertex is the same thing as the axis of symmetry. So for part A here, our answer is going to be x is equal to 4, right? Because the x value of the vertex, right, and the axis of symmetry, they're the same thing, okay? So that's part A. Let's take a look at part B. Find the x-intercepts. Well, that's easy. This is an x-intercept form. The x-intercepts are your p and q values. So you could just say x is equal to -1, x is equal to 9. Okay? Right here, x is equals -1, x is equal to 9. Part C, find the y-intercept. Okay? The y-intercept, right, that's when we make x equal to 0. So just plug in 0 here for x and work it out. So we get y is equal to negative, parentheses, 0 plus 1 times 0 minus 9. And then we just work this out. So this is just going to give us y is equal to +9. Okay? All right. And then the last part, find the vertex. Okay. So we already know the x value of the vertex is 4, right? So if we want to find the y value of the vertex, let me erase this real quick. So we know the x value of the vertex is 4. If you want to find the y value of the vertex now, the y value of the vertex, well, we just plug in the x value of the vertex into the problem, right? So we're going to get negative, parentheses, 4 plus 1 times 4 minus 9, right? So I'm just taking the x value of the vertex and I'm plugging it into the problem that we're given. So we're going to end up with y is equal to negative, parentheses, 5 times -5. So we're going to end up with y is equal to +25, right? So our vertex, all right, so the vertex is going to be 4, 25. Okay? All right, so let's take a look at this next example here, all right? So this question says, one of the x-intercepts of a quadratic is at x equals -7. The axis of symmetry is at x equals -3, and the y-intercept is at 5. Write the function in the form, and then they give us x-intercept form here, okay? So the most important thing to do in a question like this is to draw a picture and make sense of the information, okay? So they tell us one of the x-intercepts, right? So let's say we have, this is the x-axis. So one of the x-intercepts is at x equals -7, right? So that's this right here. It says the axis of symmetry. So the axis of symmetry, right, remember, splits the parabola in half. They're saying the axis of symmetry is at x equals -3. So it's at x equals -3. And then they give us the y-intercept is 5, okay? So the important thing to understand here is, well, remember the axis of symmetry splits the parabola in half. So that means from -7 to -3, this is 4 spaces. So that means if we move over 4 spaces from -3, that's going to give us the other x-intercept, right? So the other x-intercept is going to be at +1, okay? So now we know the 2 x-intercepts. One of them was given to us, x equals -7. And using this information, we found the second one, which is going to be at x equals +1, okay? Now, so let's write the equation. So we know y is equal to, we don't know the a. Now we know the 2 x-intercepts are -7 and 1. So these are like your p and your q values, right? So we have x minus -7, right? And then x minus 1. So right now we have y is equal to a times x plus 7, right, and x minus 1. Now we need to solve for the a value, right? Now remember, to solve for the a value, that's why they tell us this. The y-intercept is 5. Now if the y-intercept is 5, you know the coordinates are 0, 5. So what we can do now is we can take this coordinate, right, take this x and y, plug it in here and solve for the a value. So y is 5. The a is what we're solving for. X is 0. Work this out. So we're going to end up with basically negative 1 times 7. So negative 7a is equal to 5. Divide by negative 7. So negative 5 over 7 is our a value, right? So the equation in x-intercept form is going to be negative 5 over 7 times, right, x plus 7 times x minus 1, okay? All right, so let's take a look at this last example here. So we're given this function, okay? So remember, first of all, this f of x here, that's the same thing as y. You can think of it as y, right? So it's the same thing. So part A says, find the y-intercept of f, okay? So to find the y-intercept, remember that's when we make the x equal to 0. So I'll do part A1 right here. So if we make the x 0, right? So we have y is equal to 3 times 0 squared plus 12 times 0 plus 9. If you work out this out, this is just going to be 0 plus 9, so we get 9. Okay, so the y-intercept, all right, x is 0 and y is going to be 9. Okay, A2, find the x-intercept. When you want to find the x-intercept, remember that's when we're going to make the y is equal to 0. Right, so you set the y equal to 0. So if you make the y 0, so you're going to get 0 is equal to, so we need to solve this quadratic. So I'm going to take out the GCF first. So I'm going to take out the 3. I get x squared plus 4x plus 3. So I divide by 3 on both sides. So this will still be 0. So this 3 will go away. And then I factor this. This is x plus 3, x plus 1. Right? And then what's going to make the 0 when x is equal to negative 3, when x is equal to negative 1. So these are your x-intercepts. So your x-intercepts are negative 3, 0, and also negative 1, 0. Okay? Now, part B says they want us to write this function in vertex form. So we're given the function, right? We're given the problem in standard form. We need to change to vertex form. Okay? So now part B here, if we need to change the problem into vertex form, you need to find the vertex. So remember to find the x value of the vertex. If we have standard form, that's when we do negative b over 2a. So we have negative b, which is 12, divided by 2 times a, which is 3. So this is going to give us negative 12 divided by 6. So we end up with negative 2. So the x value of the vertex is negative 2. And then the y value of the vertex, we're going to just plug in the x. So we plug negative 2 into the problem. So 3 times negative 2 squared plus 12 times negative 2 plus 9. And then we calculate this and we work this out. So it looks like this is going to give us 3 times 4, so that will give us 12 minus 24 plus 9. So it looks like this is going to give us negative 12 plus 9, negative 3. Okay, so our vertex, we just found the vertex, x is negative 2 and y is negative 3. Okay, so now if we need to change this into vertex form, so we found the vertex. So in vertex form, remember this is like your h and your k, right? So we're just going to plug it in here for h and k. Now remember, when you plug in the h value, you have to do the opposite sign, right? So basically we have y is equal to. Now the a right here is the same a from standard form, so that doesn't change. So we know that's 3, right? And then we have x minus negative 2. So the negative becomes positive, right? That's why this becomes opposite, right? And then we have minus 3. Okay, so our equation will be y is equal to 3 times x plus 2 squared minus 3. Okay, so remember when you take the vertex, right, the x value of the vertex, and you plug it into vertex form right here, right? This sign is always going to become the opposite, right? So you notice it becomes a plus now inside here because we had that negative and negative, okay? So now that we've changed it to vertex form, they want us to state the a, h, and k values. So a obviously is 3, h is just the x value of your vertex, -2, right? K is -3, okay? And then, let's see, write down the coordinate of the vertex. We found the vertex already. So the vertex was -2, comma, -3, right? And then the last part, write down the equation for the axis of symmetry. Remember, the axis of symmetry is the same thing as the x value of the vertex. So the x value of the vertex is -2. So your answer is x is equal to -2. Okay?